Welcome back from the ad break, and let's continue with our lesson. So now we are going to be going into that first concept in our concept map, and that is from verbal representations to flow diagrams. Remember, we are working with those equivalent forms. So let's see here. Complete the following flow diagrams using the given statements. So the first statement that we are given here is 5 is added to an input value to get the output value. So 5 is added to the input value to get the output values. On the left hand side, we have those input values, of course, represented by that X, and on the right hand side, we have those Y values represented by our Y. So the rule that is given there in that statement says 5 is added to an input value to get an output value. So it's quite clear that the rule here is to add 5. What are we adding that 5 to? To an input value. So let's get the output values quickly. That is 4 plus 5. That is going to give us a 9. Then we have 10 plus 5. That is going to give us a 15. Then we have a 37 plus 5. Do you know what that answer is going to be? Of course, you are correct if you have 42 as that output value. So those are the output values that we got from the statement. Can you see how we were able to use our verbal representation and transfer it to our flow diagram? So our verbal representation was that 5 is added to an input value. So in the flow diagram, we had those input values that we used to apply this rule that was given verbally, and then that will give us those output values. And of course, remember that our input values are represented by an X and our output values are represented with a Y. Let's go on to the next question. The next question is also a flow diagram where we have been given the input values, and we know that those input values are represented by X, and now we are supposed to get the output values, and of course those are represented by a Y. So now our verbal representation says there an input value is multiplied by 8 to get an output value. So our rule there is to multiply by 8. Let us take that rule and represent it into our flow diagram. So we have the first input value of 2. So 2 multiplied by 8, that is going to give us a 16. Then we have 9 multiplied by 8. That is going to give us a 72. And of course, 12 multiplied by 8, do you know what that answer is? If you have 96, then you are absolutely correct. So can you see how this representation, or two different representations, are actually representing the same thing? An input value is multiplied by 8, but that can also be represented in a flow diagram. Let's look at the next question. The next one there also is a flow diagram that we need to now represent, or a verbal statement that we need to represent in our flow diagram. It says there an input value is divided by 3, and then 4 is added to that quotient to get the output value. So there are two parts of our verbal representation there. We know that we must divide by 3 first, and then after that we are going to add 4. So let's get to those input values that are going to give us our output values. So a -3 divided by 3 will give us a -1, but when we add 4 onto that, our answer is going to be yes, a 3. The next one there is 18 divided by 3. Now 18 divided by 3, that is going to give us a 6. But when we add 4 onto that, that is going to give us a 10. What about 33 divided by 3? Do you know what that is? Yes, it is a 11. And of course, when we add 4 onto that 11, that is going to give us an answer of 15. So those are our output values. Again, can you see how this verbal representation of our diagram has been now represented in a flow diagram? Verbal representation of our rule has now been represented in a flow diagram. Let's look at more examples. We have an input value is multiplied by 4 and then 2 is subtracted from that product. So the first part of our rule is to multiply by 4, and the second part of our rule is that whatever result we get from the first part of our rule, we are going to subtract by 2. So that is our rule that we are now going to take this representation and put it into a flow diagram. Let's look at our first input value, which is -2, and see what output value it is going to give us. So -2 multiplied by 4, that is going to give us a -8. Yes, you are correct. So -2 multiplied by a -4 is a -2 multiplied by a 4 is a -8. Then from that -8, we are going to subtract 2. That is going to give us an answer of a -10. What about the next input value? 0 multiplied by 4? Yes, that gives us an answer of 0. And when we subtract 2 from that, we are going to get a -2 as the answer. Then we have 15 multiplied by 4. Do you know what that is? Yes, it is a 60. So 15 multiplied by 4 gives us a 60, and from that product we are going to subtract 2, meaning our answer is going to be a 58. And that is how we have represented that flow diagram. Let's look at the next question. Now, the next question here, we are given the verbal representation, so it is written there for us and it is given to us. So when we read it, we know what we must do. But when we look at our flow diagram, we have been given the output values, which are the Y values there, and we need to now find those input values. It says there, a input value is multiplied by 5. So we know that whatever value we start with here is going to be multiplied by 5. And then 3 is subtracted from that product. So we are going to subtract that product. But as we have seen in other examples as well, if we are given the output value, which is the answer, we are going to use the additive inverse and the multiplicative inverse to get to our input value, which is what we initially started with. So let's look at those output values and use the additive inverses and the multiplicative inverse. To start with, the additive inverse of a -3 is a +3. So the additive inverse of a -3 is a +3. And of course, the additive inverse of a 5 being multiplied by 5, that is going to be 1/5, which is the same as dividing by 5. So let's use the output values. 7, and since as well we are working backwards, we are going to use the additive inverse. So 7 plus 3, that is going to give us a 10. And from that 10, we know that an input value was multiplied by 5 to get that 10. So we are going to say 10 divided by 5, and that gives us a 2. So that 2 was our input value. Let's move over to the second output value. We have been given a 37. So that's 37. We are going to add 3, and that gives us a 40. And from that 40, we are going to divide by 5. That is going to give us an 8. And if we just check, 8 multiplied by 5 is 40. And from 40, when we subtract by 3, that is going to give us a 37. Let's look at that last output value. That is 52. Now, 52 plus 3. Remember, we are using the additive inverse because we are working backwards. So 52 plus 3 will give us a 55. And when we say 55 divided by 5, that is going to give us an 11. So 11 multiplied by 5 is 55, and from that product we are going to minus a 3, and that is going to give us a 52. Let's quickly go to an ad break, and then we'll see you now for the rest of our lesson.